Communication and completed his research from Indian Institute of Technology, Roorkee. His research including 5G communication and beyond IRS, UAV communication, D2D communication, millimeter wave communication, energy harvesting issues in 5G communication, ultra wideband communication and IoT communication, and different areas of image processing and signal processing, including machine learning, deep learning, and its application in healthcare communication and signal processing. He has published various research papers, research articles in different journals of Scopus SCI and different national and international conferences and book chapters. He has granted an Australian innovation patent and German innovation patent. He is an active reviewer of various reputed journals and has reviewed more than 50 papers up to date. He has supervised many PhD students in the area of wireless communication and medical image processing, and also in V2X communication. And his teaching area interests including communication and telemetry, wireless communication, digital signal processing, advanced signal processing, image processing, computer network, and different areas of latest communication technology. So I welcome Dr. Ranjay Hazara sir to this FDP program and request him to kindly start the session, sir. Dr. Ranjay sir. Please start the session, sir.
So, good morning all. Thank you very much. Thank you, Mr. Singh. Thank you, Pankaj sir, and all the faculty members, dignitaries, the chairman sir, the chancellor sir, for inviting me. So, before I start my session, let me first share my screen, and then I'll just start my session. So, kindly tell me if it is visible or not. Okay. Is it visible to all?
No, sir. Currently,
not yet. Just give me a second. Just give me a second. Just give me a second. Sir, could you just stop sharing from your side? Because
sir, yeah. You just start sharing from your side, so it will automatically.
I am unable to share because they are currently telling me that you have already shared one screen. So, if you could stop sharing that, then it would be good.
Now, sir, now it's okay. You can try.
Sir. Okay, sir. Is it visible now?
Yes, sir.
Okay, thank you. Thank you very much. So, a very warm good morning to one and all. Okay, so today I'll try to finish my presentation within an hour or 10 minutes. So, the topic on which I'm going to present is intelligent reflective surfaces enabled device-to-device communication for 5G and beyond networks. Okay. And as I've been introduced, I'm Dr. Ranjay Hazra, working as an assistant professor in Department of Electronics and Instrumentation Engineering, NIT Silchar. So let me just start off the session. So I request all of you to kindly mute yourself so that there is no such disturbance from my side also. So kindly mute yourself from the other end. Yeah, so thank you all. Let's start. So as you know, the talking about the generations or the growth of mobile technology in the last few years, we have seen that during the last 40 years, there has been a transition from first generation to the second generation to the third generation to the fourth generation. Now we are currently into the fifth generation. So talking about the first generation technology, it was all about voice communication. We had those handheld phones which were very heavy, and the technology on which it was based was your advanced mobile phone system, with a maximum data rate of 2 kbps. So you can understand the phones which were there in 1G time had a capability or had a data rate of maximum 2 kilobits per second. Okay,
क्लास
and
कोऑर्डिनेटर को
with
दे दो.
and with that service there was only possibility of only voice communication in that case. Now when we move from 1G to 2G, that is, we move from first generation to the second generation cellular technology, we came up with two more standards. One was GSM, which was known as Global System for Mobile Communication, and CDMA, which was known as Code Division Multiple Access. Now, uh, as we move from 1980s to 1990 with the evolution of 2G, we saw that there was the capability of voice communication along with SMS service being provided. Now, the data rate was still very less. So we moved from a data rate of 2 kbps from analog or 1G to 10 kilobits per second in 2G. But still, the services which were provided was only about voice and SMS. So
अच्छा.
as a result, this led us to the evolution of one more standard, which is 2.5G, which was known as General Packet Radio Service, or GPRS. Now, GPRS was the first such technology which gave us the feature of MMS. If you remember those features, those Nokia phones at that time had the features of MMS also. So 2.5G was the first standard which actually led to the evolution of your GPRS. We still didn't have data communication at that time. Now, when we moved from GPRS to Edge, which was about 2.75G, we got the facility of your data communication. So we then had voice, SMS, MMS, and
अरे
data
लॉगिन कर लो,
communication.
लॉगिन
We
करो,
had
लॉगिन.
those. We had those facilities of voice, we had those facilities of data, and we had those facilities of your SMS also. Okay, so these
कौन सा
were
उसे पता नहीं.
these were some of the capabilities which we had till 2.5 or
मुझे याद तो तब है जब उसे पता ना हो.
2.75G. Okay.
और इस मामले में आप ये मत सोचो कि लड़की का कुछ बिगड़ा.
Sir, could you kindly mute yourself? Kuldeep sir, could you kindly mute yourself? मुझे आवाज आ रहा है actually. Yeah, thank you. Yeah. So let's come back. So in 2G GSM communication, the data rate was 10 kbps. So once we moved from 2G to 2.5 and 2.75G, we saw an evolution or the increase in data rate from 10 kbps to 100 kbps. Okay. Now the advantages we had at that time was we had the facility of your voice, we had data, and we also had your SMS service. Now when we move from 2.5 or 2.5G to 3G, the technology which we had, or the standard which we had, was UMTS, Universal Mobile Telecommunication or Telephone System. Now when UMTS actually came into the picture, along with UMTS we had CDMA 2000, we had wideband CDMA, the data rate automatically jumped from 100 kilobits to 2 Mbps. So you see, in every generation there is an increase in data rate also. And the most important feature is that in 3G we had voice, we had data, we had SMS, MMS, and we also had the facility of your online video calls. So the video calling facility first was introduced in 3G, that is in the year 2000 onwards. But obviously in India, we got the facility of 3G after 2007 or 2008. Okay. Now, we moved from 3G to 3.5G, which was high speed packet access, or HSPA. Obviously, the data rate also increased from 2 Mbps to a maximum of 42 Mbps. Currently, in 4G LTE system, 4G, which is the fourth generation, we have a maximum data rate of 300 Mbps. With the two main standards which have been introduced in 4G is LTE, which is long-term evolution, and WiMAX. So with these two standards, we are able to get a maximum data rate of 300 Mbps. As we move from 4G LTE to LTE Advanced, we are now expecting a data rate of 1 Gbps. In India, recently a Prime Minister has also launched the services of 5G. Okay, so before I move to the 5G services, talking about the 4G, so what was the features of 4G? It was voice, it was SMS, it was data, it was video calling, it was IP telephony. So please remember, everything in 4G is actually IP based. So whether it is IP telephony, whether it is high definition television communication, whether it is video conferencing, whether it is online gaming, whether it is online streaming, in 4G, everything is IP based. And that has led to the evolution of data rate from 42 Mbps to currently 300 Mbps. Yeah. Now, since 5G has already been launched in India, let me first clear what 5G is all about. So if I talk about 5G, we say with help of 5G, very high data rate can be achieved. It has a very large bandwidth, very good. But at the end of the day, do we have that infrastructure to support 5G speed? No, not currently, because the maximum data rate which has currently been achieved in 5G is 1 Gbps. But we expect a 5G standard to go maximum to 10 Gbps. For that, we need a good infrastructure. We need a good a front haul and a back haul kind of a system, so that we are able to provide the necessary infrastructure to develop 5G. Now, please remember, 5G or the fifth generation is not a single technology. It's a culmination of various technologies. For example, visible light communication, millimeter wave, device to device, small cell, etc. and etc. Now, with fifth generation, what was the expected features? We expected to have a very high spectral efficiency, that none of the spectrum will remain unutilized. So that is the first point. The second point is environmental friendly. Environmental friendly means it is highly energy efficient. Third, capacity. It should have a very high capacity. Very high capacity in the sense that it should be able to support innumerable number of users. Okay. The next point, cost effective. Obviously, whenever you go for a higher technology, it must not come at the lower cost. It must always come at a higher cost. So it must be cost effective. At a lower cost it must come. And last but not the least is intelligent. Your 5G technology must be intelligent. Intelligent in the sense, it must have the facility of IoE. Okay, it must be able to make autonomous decisions based on the sensing capabilities. So all these things, or all these features, make 5G a standard which is for supporting high data rate communication, high capacity and low latency. Latency here means a very less amount of delay should be present. Yeah. I move to the next slide. So what is the challenges of 5G? The major challenges of 5G is, at the present moment, we have a very high traffic volume. Why? Because we have n number of mobile users which are connected. So if you have n number of mobile users which are actually connected, so the biggest challenge is managing the data from all the users. Please understand, at present we have 50 billion devices which are connected over the network. So all the data from all those users, the large amount of traffic which is being generated from all those users, or the data which has been shared by all the users, has to be managed very well. So this is one of the major challenges. The second challenge is a number of devices which are connected. Please remember that in 5G, there are n number of devices which are connected. For example, a machine connected to a machine, a device connected to a device, a vehicle connected to a vehicle, your CCTV connected to a mobile connected to a camera connected to a car connected to a machine, so on and so forth. So you are having millions and millions or billions of devices which are present in the network. And not only they are present, they are not only connected, but they are also sharing their data at the same time. So this is one of the major challenges of 5G, if I may put it in that way. Okay. Now, challenges is a part, but the other advantages with the advent of 5G, you are having now a good number of use cases. For example, whether a device is able to communicate with a device, whether a vehicle is able to communicate with a vehicle, whether a machine is able to communicate with a human, whether a human is able to communicate with a device. So all these added features have made the challenges of 5G more and more. Okay. Now, what is the vision of 5G? Talking in terms of the services, we expect a 5G to be having bandwidth everywhere. Bandwidth everywhere means ubiquitous bandwidth, means bandwidth is present everywhere. We are expecting to have a very high bandwidth. The second one, whatever quality of data is being shared should be of the quality of a high definition quality. Okay, so that is also one of the expectations. The third being internet of everything. Okay, so it is not just internet of things, it is basically, when I talk about internet of everything, it is combining people, process, data and things. So please understand, internet of everything is combination of people, process, data and things. So by this I want to say it is the intelligent connection of people, process, data and things. So data must be intelligently being transported such that intelligent decisions can be made. People can be connected in n number of ways. Process means the information must be delivered to the right person at the right time. And things means you can have n number of physical devices, machines or vehicles which can not only be connected among themselves over the internet, but also they should share their information among themselves. So internet of everything is the combination of people, process, data and things, and that is what makes it intelligent. So M2M is machine to machine, M2P is machine to person, and P2P is person to person. Clear? The fourth service is sensing, the presence and ad hoc networking. So the advantage of 5G is it can form an ad hoc network at any time. Ad hoc means a non-centralized kind of a network. For example, a PC, a mobile, a printer can form a network on its own without having any one device taking the charge over the other. So if it's a ad hoc kind of a network which can be formed, then we can say that it is able to visualize or it is able to satisfy one of the needs of 5G. And at the end of the day, it is an ecosystem of having various other applications. Now, what is the requirement of 5G? The system capacity must be very, very high. By the system capacity, I mean that we may be able to satisfy n number of users. So if I compare the system capacity of 5G with 4G, I can say 1,000 times more users have connected. High data rate. So the current data rate which is expected in 5G is around 10 Gbps, which is 10 times to 100 times the current 4G data rate speed. The latency means the delay time. For any communication, it is better to have as much as less as delay time as possible. So it is expected in 5G to have a delay time of around 1 millisecond or below. Mass connectivity, we are expecting 100 times more devices to be connected at the present moment. Then it must be an energy efficient network. Energy efficient means that your device, if it is communicating with any other device or any machine, if it's connected, your efficiency must be as low as possible. Your device must dissipate very less amount of energy. So these are some of the visions of your 5G. So if I move towards the evolution of 1G to 5G, we see the 1,000 times more data volume has to be tackled. 10 to 100 times more devices have been connected. We expect 5 times less latency. We expect 100 times more data rate, and we expect the battery life to be 10 times more than what was expected in 4G. So with these advantages, 5G is the future of wireless communication. Now, what I was talking a while ago is all about the big picture of 5G. So as you can see in this entire diagram of 5G cellular architecture, you see various technologies, one being small cell, massive MIMO, wireless sensor networks, Internet of Things, device to device, and network function virtualization. So as I already told, 5G cellular network architecture is not a single architecture. It is a culmination of various technologies, because at the end of the day, all these technologies are meant to satisfy those 5 goals. What are those 5 goals? High data rate, less latency, high capacity, and to achieve that, your major goal should be to satisfy so many number of users. Okay. Now, if I talk about 5G, 5G is a part of third generation partnership project, which is also known as 3GPP. Okay, under the release 15, it is said that 5G should target 3 things. What are those? Enhanced mobile broadband. Okay, so your data rate should be very, very high. Second is ultra low latency, URLLC. So your latency should be as less as possible. And the third is MMTC, which means massive number of machines should be connected in 5G network. So with these 3 goals, all these technologies which I spoke about will actually try to satisfy these points. Okay, so if I talk about a small cell is nothing but a low powered base station whose range is from 10 meters to a few kilometers. If you remember, or if I can say, a small cell can be classified as a femtocell, as a picocell, and as a microcell. The radius of a femtocell is only 10 meters. The radius of a picocell is only 200 meters, whereas the radius of a microcell is less than 2 kilometers. And if you compare that with a normal base station, the radius of coverage of a normal base station is around 30 to 35 kilometers. So with this, can we then say that if a small cell is being used whose coverage is very, very less, what is the advantage of having a small cell? The advantage of the small cell is that if I have a small cell whose radius is very small, so I am basically catering to those users who are present in that small area. Thereby what I am doing, I am increasing the capacity. So that band or that frequency which I am using in that coverage, I can also use that frequency in some other portion of your cell. As a result, what I can do is that I can multiply, I can diversify my cellular band which has been given to me. So what I am doing at the end, I am trying to increase the capacity. So I am catering to more number of users, as well as I am trying to increase the spectrum efficiency. I'm not wasting the efficiency. I'm not wasting the spectrum. I'm reutilizing the spectrum. So this is one of the advantages of having a small cell. Then going to the next is a cognitive radio. A cognitive radio, we all know, is a form of wireless communication where the transceiver can intelligently detect which communication channel is empty and which communication channel is is filled up. So in the scenario where the communication channel is filled up, the transceiver will not at all touch that band, but where the transceiver will find out that the spectrum is empty, the transceiver will automatically use that vacant channel. So as a result, what this cognitive radio will do is that it will utilize that band which is lying empty. In a way, it is trying to increase the efficiency of the spectrum. It is not wasting any spectrum which is lying vacant. So as a result, it is increasing the quality of the service of your communication. Talking about MIMO. What is MIMO? MIMO means multiple input antennas and multiple output antennas. So if you have an architecture where there are multiple input and a multiple output antennas, the major advantage with that is I will be exploiting the diversity. So the data from the transmitter to the receiver can flow through multiple number of transmitters as well as through multiple number of direct link or through relay network. So when you have multiple transmitters and multiple receivers, your receiver will receive multiple copies of the same signal or different signals which have been transmitted from the multiple transmitting antennas. So as a result, what will happen is that you will get multiple copies. In a way, you are going to increase the diversity. The only difference between a MIMO and a massive MIMO is in MIMO you might have 2-4 antennas, 2 to 4, yeah, maximum 5 antennas at the transmitter and the receiver. In case of massive MIMO, you are going to have more than 20, or not more than 20, you're going to have more than 50 antennas both at the transmitter and at the receiver. So you can understand, if there are 50 antennas at the transmitter and the receiver, and you are able to control their interference, then you are able to understand how many copies of transmitted signal I will be able to receive at the receiver side. So as a result, my diversity will increase, my data rate will increase, my link reliability will increase. I will be achieving multipath propagation. But only thing which I have to, which would be challenging for me, is to control the interference coming from the other users. So if that is controlled, there's a high chance that I will be able to achieve high data rate and a high spectrum efficiency, which is one of the requirements of 5G. Okay, going to the next technology, which is the device to device. In case of device to device, as you can say, it is the direct communication between two users without traversing through the base station. Now we know that in any cellular communication, if any mobile user wants to communicate with the other mobile user, it has to be via the base station. The advantage with D2D or device to device is that base station is not required for transferring or for sending any data from one user to the other user. So what is the advantage? First and foremost, if there is no base station, your latency is reduced. Isn't latency one of the targets of 5G communication? Yes. Further, if I am having two devices which are in very close to each other, which are in proximity of each other, what kind of a data rate I can achieve? I can achieve a very high data rate, because the coverage area in which the two devices will communicate is a very small range. So that is also one of the features which makes 5G, or which makes D2D one of the suitable candidates for 5G communication. Now, talking about the next architecture is wireless sensor networks. So what is the job of a wireless sensor network? It's a network which consists of n number of wireless sensor nodes, which are actually forming an ad hoc kind of a communication among themselves, and they are sharing the data. So the data could be an environmental data, it could be XYZ, any kind of data. So what is the advantage with WSN? The advantage with WSN is that the sensor nodes are continuously exchanging data among themselves, and they are also following the architecture of an ad hoc network. So as a result, what is happening is that since they are always communicating, so there is no spectrum which is expected to be lying vacant. So as a result, we are achieving spectrum efficiency with the help of a wireless sensor network. So with that, we are able to cater to one of the needs of 5G communication. The next one is a visible light communication. Please remember, visible light communication is only possible at terahertz region, that is from 400 to 800 terahertz, with a wavelength of 780 to 375 nanometer. Now, if I am transmitting an optical signal at a very high frequency of 400 to 800 terahertz, one can imagine the high data rate I can achieve over there. So since data rate, achieving high data rate is one of the conditions of 5G, so therefore visible light communication is also a part of 5G. Taking one more technology, which is millimeter wave technology. Millimeter wave technology is a technology which is present between 30 gigahertz to 300 gigahertz. Now, this is also a very high frequency, 30 to 300. So at this very high frequency, very high data rate can be achieved, very high capacity can be achieved, more in number of users can be given that service. But the problem with millimeter wave is that it has a very high path loss. So if this high path loss can be somehow tried to be mitigated, then obviously at the end of the day, millimeter wave could be said to be one of the futures of cellular communication. So maybe there might be a time which might come where we might shift from cellular band to probably millimeter wave band for mobile communication. Okay, if there is such requirement in the future. Last but not the least is IoT. What is IoT? As we already said, it is a communication of n number of objects. It could be machine, it could be vehicle, it could be any roadside unit, it could be any device. But the advantage is they are all connected over the internet, and they are also sharing data among themselves. Thereby, it is expected to have a high data rate. Okay. And last is network function virtualization, where a virtual network is created. So a virtual framework is created, but the function is similar to a wireless communication network. So you are basically performing the function of a wireless setup, but at the end of the day, there is no such physical connection which is there. It is all a virtual network. So in the advantage of virtual is that you can create a virtual network by using a software, and the advantage with that is you can add, you can delete any such device, and at the end of the day, whatever data rate is expected to be achieved, that can be achieved from this 5G. Now, talking about 5G and beyond. So 2G was all about voice and SMS. 3G was all about voice, SMS, data. 4G was all about voice, data, SMS, and video calling, online gaming, IP streaming, and all. 5G was all about combination of all technologies, whereby we could basically target all industrial IoT applications and interactive video sessions. 6G. So our now target is 6G, which is expected to be launched by 2030. If I talk about 6G, the biggest advantage of having 6G is we are expecting a data rate of more than 100 Gbps to around 1000 Gbps. One can imagine that if we are able to achieve a data rate of around 100 Gbps to 1000 Gbps or 1 terabits, so how fast the communication will be. Now, for 6G to be achieved, it is expected it would be all based on some kind of an or of all kind of a holographic telepresence. Holographic telepresence, as one knows, it's a technology which allows users to project some realistic full motion or a 3D images of people and objects in real time. So you are basically creating users who are actually present remotely, and you are projecting them as if they are present in real time. So we've all seen how a holograph looks like. So in 6G, we expect some kind of holographic video kind of a communication taking place. And also, the most important, 6G is incomplete without the two technologies. One is massive AI and machine learning and deep learning. So these capabilities or these technologies, I think, would make 6G one of the futures. So when I talk about AI is just not about machine learning and deep learning. It is also a combination of augmented reality and virtual reality. The only difference between a virtual reality and an augmented reality is that in case of augmented reality, we are adding computer generated information also. Now, what is a virtual reality? Virtual reality is, as far as users perception goes, it is basically a representation of a user's perception of reality based on some virtual information. As you can see, all those games, when you are applying or when you are putting all those camera kind of things on your in front of your eye, you are able to see online gaming taking place. So that is something which is virtual, but to you it will look like as if it is present in a real-time scenario. So virtual reality is basically getting the feel of virtual things in a real-time scenario. That is all about virtual reality. What is augmented reality? Augmented reality is virtual reality plus the feedback which you get from additional data you get from a computer generated machine. So it is the addition of virtual plus your data which is generated from your computer, because continuously information is coming from computer also. So augmented is the addition of virtual plus your additional computer generated information. So when I talk about 6G or when I talk about 5G advanced, we are talking about capabilities from new services, extreme connectivity, security to RF sensing. So when I talk about all these new services, it is augmented reality, it is virtual reality, and it is holographic telepresence. Okay, so when I talk about extreme connectivity, we are expecting a data rate of around 1000 Gbps or 1 terabits per second, and we are also expecting the number of devices to be around 10 million devices per kilometer square. So you can understand how many devices is expected in 6G. Whereas in case of 5G, we were expecting 1 million devices per kilometer square. In 6G, it is expected to be 10 million devices per kilometer square. That is why the name extreme connectivity. Talking about security, it is expected that your 6G should be having a secured, trustworthy, perception based, autonomous networking, and all these features should be present in your security. So it should be a trustworthy, it should be a secured, it should be an autonomous networking based on effective sensing. So your system is continuously sensing, continuously getting the feedback, and it is automatically trying to update its features. That is what is expected in 6G. Okay, it could be a combination or a culmination or an amalgamation of various other heterogeneous technologies or heterogeneous devices along with other networking devices also. So that is what is expected in 5G. I'll just show you one small video what is expected in 5G, advanced 5G. Just go through this. Okay, just for 30 seconds, just watch this video. So I come back again to the slide. So talking about the uh, 5G and beyond architecture, or the advanced 5G, or about the 6G, we expect it to be sustainable in the sense that it is automatically going to be going to support our future generations also. So let's see what is the vision of 6G. So when I talk about 6G, the work of 6G has automatically started. So there are 5 different if I may call about projects which has already been started. In Europe, the project is known as Hexa-X, European 6G flagship project. In China, it is known as China's IIMT 2030 6G promotion group. In US, it is known as NextG Alliance. In Korea, it is known as Korea government's MSIT 6G R&D implementation plan. And in Japan, it is known as Beyond 5G Consortium. So all these projects which are parallelly going in these 5 countries, they are trying to get the new features. They are trying to add features what could be added in 6G technology. So if you look at the diagram on the left, when I talk about 6G, it is basically the combination of these 3 worlds: physical world, human world, and digital world. When I talk about the physical world, it deals with the interaction of the physical world with the human world. It deals with the interaction of the human world with the digital world. It also depends upon the interaction of the digital world with the physical world. So human world is all about our own senses, our cognition, our intelligence, and our values. Okay, what is your digital world? Digital world is all about the information, the communication technologies, and all the computing systems which are present all around us. What is the physical world? The physical world is the presence of objects, devices, organisms which are present all around us. So basically 6G is the culmination of all these 3. When I talk about the interaction between the physical world and the digital world, we talk about digital twins. Okay, we talk about rich sensor information, we talk about data mining, we talk about analysis, we talk about so huge amount of data getting not only shared, but also we want to say that the efficiency and the resilience of such a system should improve. Okay, because at the end of the day, we need massive data communication. Talking about the interaction between the human world and the physical world, it is mainly aimed for improving the feedback, for looking into the control part. And talking about the interaction with the human world, with the digital world, it is all about cognition. It is all about sync kind of an effort. That is, the assistance should come from AI, ML, and other technologies. So there is a culmination of all these technologies. Please remember, the vision of 6G is set to come in release 18, which is the 5G advanced era. It is again comes under 3GPP. So till now, 3GPP has already released 15. The release 15 is all about 5G. Release 16 and 17 tells about the industrial IoT application of 5G. Release 18 under 3GPP is all about advanced 5G and 6G communication, which is set to be released in 2024. Now, talking about 6G, the main 3 points which a 6G should have is trustworthiness, inclusion, and sustainability. So when I talk about trustworthiness, what kind of a trustworthy it is? The trustworthiness for 6G to, to be basically the backbone of your 6G communication technology. Inclusiveness, I mean that it should be available to everyone and everywhere. And by sustainability, I mean to say that whatever the technology 6G is trying to achieve, it should be towards a global development for environmental, for societal, and for all economic needs. Okay, so that is all about your trustworthiness, inclusion, and sustainability. Okay, now moving to one of the key challenges of your technology advancement in case of research is basically the connecting intelligence, network of networks, sustainability, global service coverage, extreme experience, and trustworthiness. So these are the few challenges which are there in 6G. So when I talk about connecting intelligence, I say there should be a presence of augmented reality, there should be a presence of virtual reality. All the devices which are present must be intelligent enough so that they can not only interact with human, but they can also make autonomous decisions on their own. When I talk about networks of networks, I say it is integrating millions of networks, millions of sub networks, so that we are able to communicate, achieve a good communication, we are able to share data, and at the end of the day, all these should be achieved with the help of AI and more advanced versions of AI. Third is sustainability. When I talk about sustainability, whatever network, whatever communication happens, at the end of the day, your system must be having a good energy efficiency. When I talk about global service coverage, I mean this is meant for everybody and everywhere, and your connectivity should be very, very fast. When I talk about extreme experience, by extreme experience, I mean that it should push all the boundaries in the sense that the data communication should happen at a very high data rate, 1 Tbps. N number of users should be connected, a very high capacity. My delay time should be very, very less. In 5G, we have seen the latency to be 1 millisecond. It is expected that in 6G, the latency will be in nanosecond. So one can understand the amount of delay time has been reduced to a lot. Okay, and finally, it must, your whatever 6G network you have chosen, it must be trustworthy in the sense it must be secured, it must have privacy, it must be self-reliant, and at the end it must be reliable in the sense if there is any catastrophe, it must be able to recover from that problem. Okay, now talking about metaverse. Okay, when I talk about 5G and advance, or when I talk about 6G, it is basically all about digital world. As you can see over here, a person is basically taking those 5G realistic what to say spectacles, through which he is able to see not only a virtual things, all virtual things are now possible, or now being integrated into the real world. So such kind of features is possible through metaverse. So metaverse is a partial or fully immersed digital network experience that brings together people, places, objects in real time. Okay, so all these virtual people connected at remotely, places at remote places, information at remote places, all these things which are present remotely or which are present in virtual domain, all would look like as if they are connected in a real domain. So some kind of a digital experience is possible through this term metaverse. Okay, it is basically giving a more human kind of an experience. It is expected that it will improve our education system, it is expected to improve our healthcare system, and provide, and commercially it is going to provide us more business kind of an opportunity. Talking about metaverse, talking talking about your metaverse, talking about this metaverse, one thing is sure, or one thing I want to say is that the metaverse can be used the one thing with metaverse I can say that metaverse has huge amount of applications, whether it is in augmented reality, whether it's in virtual reality, whether it is in gaming sector, whether it is in communication sector. There's a huge amount of expansion which is going on. Okay, now talking about the main part of metaverse, these four things, the four E's: extension, experience, excellence, and expansion. These four innovative domains of 5G Advanced actually complete your metaverse. So if I talk about this metaverse, it is expected to offer improved experience for people and machines, extension for new cases, expansion to offer new services which is beyond your pure communication, and at the end of the day, all these would be powered by innovation and provide excellence. So in excellence, as you can see, excellence is a subset of extension, experience, and expansion. So this is what is expected from 5G Advanced or 6G metaverse. Okay. Now, the advancement of 5G, please remember one thing which 5G Advanced actually talks about. It is there in all the research papers. It is all about extended reality. Extended reality means whatever you are thinking is present in virtual, that can actually be perceived in your real-time scenario with the help of AI, with the help of ML, with the help of core network, and with the help of your RAN, that is radio access network. So all these things have made this possible. Okay. Now going to the next slide, as you can see, the key service categories which drives the 6G or which is going to drive the 6G is universal internet. So your internet service must be very, very high. It must be able to support video IoT service. It must be able to support speech service. It must be able to support low power, low power wide area kind of an IoT service. It must be able to support high amount of messaging service. And at the end of the day, what is expected in 6G is 100% coverage must be there. Okay. The next part, which is very, very important, is next generation enhanced mobile broadband. We have seen in case of 5G, we are targeting enhanced mobile broadband. In case of 6G, we are targeting next generation enhanced mobile broadband. That is, we are able to give them a heterogeneous capacity. We are able to give them a more uh, better features of a broadband kind of a connectivity. Okay, where we can have video features, where we can have fixed wireless access and all those. The third part being dependable real-time communication. So anything which is virtually present must be now be perceived in real-time scenario, whether it is a holography, whether it is digital twinning, whether it is remote X, whether it is gaming, whether it is automation, whether it is industrial IoT, anything must be perceived in real-time scenario. The next being sensing. Your 6G must have the capability of automated sensing. Okay, by automated sensing means where is your position of the device, at what location is it present, what is the timing, it all must be automated. Okay, that is why we say there is an interaction between the physical world, between the data world, and between the digital world. So if these things have to be achieved, then your automated sensing capacity or automated sensing feature must be present. Next part is proximity communication. Your 6G must target your proximity. Any number of devices, objects which are present very close to each other must be able to communicate among themselves without taking the advantage of roadside units, base stations, etc. and etc. And at the end of the day, your short range, even if your communication is of a short range communication, it must have a very less latency. So these are some of the service categories of your 6G. Talking to the figure 6, if you look at the figure 6, 5G advanced and the 6G spectrum options, you can see 6G can work even at a bandwidth of less than 1 gigahertz. It can work even from 1G to 10G. it can even work above 10G, it can even work in terahertz range also, depending upon what kind of an application you want. Okay. Say suppose if you want to work in sub 6, obviously you can have all the IoT applications getting covered. If you want low latency or massive MIMO communication, you can move from 1G to 10G band. If you want efficient design, if you want n number of users to be connected, you want very high data rate communication, you can move to sub terahertz or terahertz range. So these are some of the features and the options which are available. Now talking about another very important point, if I move from 5G to 6G, some of the very important points which have to be targeted is key performance indicators. The key performance indicators, as you can see in figure 7, is data rate, user experience data rate, network energy efficiency, localization, latency, connection density, and reliability. So these are some of the key performance indicators. When I talk about key variable indicators, those are something else. Key variable indicators are basically sustainability, trustworthiness, connection intelligence, network of networks, global service coverage, and extreme experience. Talking about the KPIs, it is expected that in the user experience data rate in 6G is around 1 Gbps, whereas the peak data rate is more than or is around 1 terabits per second. The spectrum efficiency is expected to be 5 to 10 times of that of 5G. The traffic capacity is expected to be 1 gigabit per second per meter square. The latency, as I told you, is around 10 to 100 microsecond. So such less is your latency which is expected. Okay. And what about the technologies which it can support? The technologies which it can support is terahertz communication, spatial modulation MIMO communication, laser and visible light communication, orbital angular moment communication, multiplexing, blockchain kind of a communication, quantum based communication, and AI based communication. So this is what is expected in your 6G kind of a communication. Also, when I talk about a digital twinning, please understand digital twinning can monitor, can design, can simulate, can analyze predict the behavior of any physical system. And how is this done? This is done digitally. So digitally, it is as if in case of digital twinning, you are digitally replacing a physical asset or a physical environment in the virtual mode. So this is what is all about digital twinning. Okay. Now, as you can see, remote collaboration. So any kind of remote kind of a communication is possible. Obviously, augmented reality and virtual reality are the part of 6G. Volumetric video. There is no end to the amount of video you can share. Computer vision, any kind of image processing, any kind of image sensing, any kind of medical image applications are possible. And at the end of the day, bio sensors, obviously, any wideband body area communication or body area devices can also be connected. Going to the figure 8, HexaX, which is a European-based project, it expects that 5G must be able to cover these features: positioning, millimeter wave, massive MIMO, SON, which is your I'll just come to SON, just to give me a moment. NFV is all about network function visualization, ultra reliable, low latency, industrial IoT, machine to machine, non-terrestrial network, integrated access backhaul network, and so on and so forth. SDN is software defined networking. So all these technologies which are a part of 5G would now be explored into 6G, in the sense that all these technologies, MMTC, NTN, IAB, IoT, would give you a human machine interface, would give you an access virtualization, would give you a beamforming kind of a technology. Beamforming is nothing but a directional communication. So if you have a directional beam being transported from the source to the destination, obviously that would help you in directional communication. So all these points are catering to all these 6 KVIs of 6G, sustainability, radio performance, trustworthiness, connection intelligence, network of networks, global service coverage, and extreme experience. Now, talking about a 6G four-tier network, as you can see, this is a radio access node. The main work of a radio access node is to communicate with the other devices or the other nodes through this radio link. Okay, so in this diagram, I'm not going to go into much details, but I'm going to target these four things. One is a space network, the other is the air network, as you can look into that. The third one is your terrestrial network, and the fourth one is the underwater sea network. So in as we move from 5G to 6G, in space network we are going to target all the low orbit satellites, the medium earth satellites, and the geostationary earth orbits. So all these things would be targeted in case of your space network. In case of air network, there could be flying base station, there could be UAVs for accessing those air network. As far as terrestrial network is concerned, we can choose vehicle to vehicle, we can choose device to device, we can choose cloud RAN, we can choose distributed RAN for targeting all those terrestrial network. As far as underwater is concerned, we can we can target mainly for a short range, because it is very difficult to go for underwater or sea kind of a network, because um, you take any technology, after certain amount of time there is going to be losses. So the major target in underwater is to first select the coverage area and then go for your communication. Okay, so talking about the technologies in 6G, we are mainly targeting these things. We are mainly targeting some of these performances, which is channel modeling, which is distributed MIMO, which is beamforming, waveform modulation, huge coverage, and all those things, and spectrum efficiency and energy efficiency. So if I take all these things into consideration, that is what is being taken care of all these 5 or 6 different countries which are working on those projects. Okay, now talking about the application, it can be security, it can be autonomous robots. So it is not just simple robots, it is commercial robots. Because in 6G we are expecting the robots to make autonomous decisions. Location aided communication, if you want to have a communication at any remote place, that must also be targeted by this. The figure which you see at the bottom and figure 10 is all about is all is all about the band which it covers. It is right from 1 megahertz to 10 picohertz. So it is expected that 6G is not only going to cover 1 terahertz but also beyond that. Okay, and this has been taken from this paper of IEEE Access. Okay, so these are some of the technologies which 6G is going to target. Now, if you remember, a while ago we spoke about connecting intelligence. Okay, if you look over here, yes, so connecting intelligence, yes, so connecting intelligence, how is this connecting intelligence achieved? It can be achieved by using AIML, or it can be done by using intelligent orchestration. So in case of intelligent orchestration, it is basically the combination of all the networks. For example, it could be a seamless integration, it could be adaptive monitoring, it could be management of all these networks. And in case of AIML, it is basically integrating all the features of AI in this technology. Okay, I will not go into much details because then we have to discuss all of them one by one. So I'll move to the next part. When I talk about the network evolution and expansion, we started with privacy preservation. We moved to flexible topologies by integrating device to device. We spoke about low latency. We spoke about radio access node. We spoke about cognitive radio. We spoke about n number of devices getting connected. So all these things have been integrated, and that is what is how the expansion of 6G would actually look like. Okay, so 6G is expected to look in this way. Now, when I talk about the 6G use cases, as you can see, the KPIs, that is the key performance indicators, are latency, bit rate, energy efficiency, outage probability, spectral efficiency, complexity. So coverage, connection, sensing capabilities, so all these would form the part of KPI. Whereas KVI, which is the key variable indicator, is the application of all these. That is, how much is the preservation, how much is the privacy expected, what is the service availability, how much trustworthy is your network, how intelligent is your network, uh, how 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 flexible is your deployment, and all these things. Okay, so the most important part of 6G use cases is based on these key performance indicators and key variable indicators. Okay, so as you can see, our target is sustainable development, massive twinning, telepresence, holographic telepresence, robots to cobots, which is commercial robots. So if all these things can be integrated together, then we can say it is able to achieve a 6G kind of a feature. Now the technologies is terahertz, already spoken, supermassive MIMO, thousands of antennas would now be connected. Now we intelligent reflective surfaces, this is on what we are going to talk about. Holographic beamforming, orbital angular momentum, laser communication, visible light communication, blockchain communication, so on and so forth. Now, when I talk about sustainability, sustainability is not in only in terms of energy efficiency. It is in terms of all these 17 goals which have been designed by United Nations. So if all these 17 goals can be covered, we say 6G can create a sustainable technology. Okay. Talking about a device to device, as you can see in this architecture of 6G or in this device to device, you see two devices are directly communicating among themselves. So if this device wants to communicate with this device, it can communicate directly without taking the help of this base station. And if this device communicates directly with this device, what will happen is that your latency would reduce, your coverage area would increase, and your data rate, expected data rate, is said to be very, very high. Okay, so this is all about device to device. I'll move ahead. So when I talk about device to device, as I already told, it is the direct communication of two devices without taking the help of any network infrastructure. The network infrastructure in this case is the base station. Okay, what are the potential applications which are expected? The potential applications which are expected is proximity based communication, energy harvesting based communication, IoT based communication, vehicular ad hoc based communication, and most important being safety all around these technologies. Okay, now talking about the mode selection, basically device to device can work in two ways. One is the in-band and the other is the out-band. In case of in-band, what happens is that the band which is provided is being shared by both cellular users as well as by D2D users. Okay. In case of out-band, what is happening is that the D2D users have been given a separate unlicensed band for communication, whereas the cellular users use cellular band for communication. So that is what differentiates the application of an in-band D2D from the out-band D2D. If you look at this diagram of the resource sharing and the interference scenario, in the diagram which is on the left, that is the figure 19, you find out in the first diagram, you find out the base station is communicating with the cellular users or directly communicating with the D2D users via the base station. So it's a direct communication. If I go to this underlay communication, you find these two devices communicate among themselves, but it is faced by interference coming from this base station, interference coming from the other D2D users, as well as interference coming from this base station. So this is the problem with underlay. Even though I say that the same resource is being shared by the cellular and the D2D users, but the major disadvantage in case of underlay D2D is the interference coming from the other D2D users and from the base station. So this is one of the major challenges of underlay D2D communication. Going to overlay D2D, as you can see, a separate band has been allocated for cellular user to communicate with the base station, and a separate band has been given for the D2D user to communicate with the D2D. Even though there is no interference, but it is a very challenging environment to carefully utilize the resource, as it is a more complex kind of an architecture. Talking about figure 20, as you can see, when these two devices are communicate directly among themselves, there is interference coming from this base station to this D2D transmitter. There is interference coming from this user to the D2D receiver. So such kind of an interference is known as intra-cell. It is within the same cell. If the interference is coming from a device which is in another cell, it is known as inter-cell interference. Okay. Now the most important topic which I was waiting for is intelligent reflective surfaces. Now when I talk about intelligent reflecting surfaces, it is also known as RIS, reconfigurable IR intelligent surface, large intelligent surface, reconfigurable meta surface, or software defined surface. So why is IRS so important? IRS is important because our radio environment is very random. Radio environment random means because the channel is continuously changing. The channel model is changing. The signal propagation is changing. The signal is once using the concept of reflection, diffraction, scattering before the signal gets or before the signal reaches the receiver from the source. So if our receiver receives multiple copies of the signal getting transmitted from the source, it is very random. We must take care of the environment. And that is where IRS plays a major role. Talking
Hello.
about the, yes, talking about the IRS,
Actually, sir, your
it's a,
current slide, which is based on IRS, actually that slide is not visible.
just a second, sir.
Okay, now it is. Now it is visible.
Is visible? Okay, sir. So talking about the IRS, it's a two-dimensional man-made surface of an electromagnetic material, namely which is called as a meta surface, and this is composed of a large number of passive scattering elements. So if I may look into the structure of a IRS is something like this. The yellow bodies which you see are all those passive scattering elements, and this is connected to one controller which is present. So all these passive scattering elements which are marked in yellow, they are responsible for making the directional beam or making the beam direct towards a certain area or a certain location. For example, if you want the communication or the coverage to be at a certain location, the objective of all these passive scattering elements which are there highlighted in yellow would be to scatter your beam towards one possible direction. Now the question is, how is it possible? How is the passive scattering possible? It is possible by controlling the phase shift of all these scattering elements. So if you are able to virtually or by using a software, if you are able to control the phase shift, then you can allow all the beams which is coming out from all these surfaces to be redirected towards a certain specific location. And that is where IRS plays a major role. So it is used for short distance communication, and for a specific area, it can be used for specific communication or a directional communication at a specific area. So as already spoken, each scattering element can be controlled by using a software which will change the EM properties, that is the phase shift. And based on the changing the phase shift, your reflection coefficient of your signal, which is getting impinged at a certain target, will also change. So either you control that by using a joint phase shift control, or you get it controlled by using some kind of passive element. It is up to you. Okay, but at the end of the day, what we are achieving is that we are achieving the vision of a smart radio environment. Okay, now if you look at this diagram, as I already told you, here say suppose there is an IRS and I want to target only this area, or I want to target this area, or I want to target this area, or I want to target this specific area, or I want to target this specific area. You can redirect your beams at all these specific locations inside a building. So as you can see inside a building, you can target either this portion, you can target here, you can target here, you can target here, you can target here. This is possible if by the use of an IRS. Now inside an indoor belt, you can put IRS at the top of a building, you can put it anywhere. In outdoor communication, you can even put an IRS on the top of a UAV, on the top of some hoardings. As you can see, this is a very you go along the road, you find several hoardings, you can put an IRS over there. Okay, if you want a communication between devices which are outside, or if you want IRS to directly communicate with your base station or other devices which are in outdoor environment, that is also possible. Okay. So talking about a meta surface, it is a planar composite structure which consists of meta atoms over a substrate, and that is the only reason which this meta surface helps in making the beam directional. I'll not go into the physics of this. So now let me go to a very important part, which is very, very important, how the IRS will help in device to device communication. So as you can see here, there is a cellular user. The cellular user beam is directed towards this IRS. The green structure is an IRS structure. So if this cellular user wants to communicate with the base station, it is the communication could be possible by two ways. One is a direct communication between the cellular station and the base station. The other could be via this IRS. So it is taking the help of this element, passive element, which is marked over here, and from there the beam is getting reflected and coming to the cellular user. So that is one possible way of communication. You can, let's look to the D2D users, how the D2D users can communicate. This D2D transmitter can directly communicate with this D2D receiver. Now please remember that inside this cell there are n number of D2D users which are present. This D2D user can also communicate with this D2D user via this IRS also. So it is not that only direct communication can happen, but if there are n number of elements which are present, this IRS will actually help this D2D user not only to communicate with this D2D user directly, but with also with the other D2D users using this relay path coming from the IRS. Okay, so this is how your D2D user would be very, very helpful in communication based on the IRS. Now, you can say by using this IRS, I can have two possible ways of communication. What are the two possible ways of communication? One is a direct path between this D2D transmitter and the receiver, and the other is via the IRS. Okay, so these are some of the advantages, or these are some of the goals which makes IRS a very suitable form of technology for not only device to device, but device to device enabled 5G or 6G communication. So I can say IRS is deployed to mitigate the interference, because if this D2D user gets interference coming from this D2D user or from this base station, I can directly take the help of this IRS to directly send the beam to this specific D2D user, and that is how this would be helpful. So it helps in reducing the interference. The second advantage is that with the help of IRS, your channel, which is between the two D2D users, the signal would be received from the source to the destination not only by the direct path but also by the relay path, as I already told you. And the cellular user can also communicate with the base station by you taking the help of this IRS or the RIS element. Now, the most important things or our understanding from IRS is IRS can be used for beam forming. Beam forming is a directional transmission. Second is energy efficient. If you are able to direct your beam towards a certain specific area, you will not waste your energy in sending your signal over a large coverage area. By using IRS, you already know from beforehand, you have to target which specific application or which specific area. So in a way, if your target, you already know that you have to cater to this user, then you can make your beam directional by using IRS and send your beam only at that point. But if you are sending your beam towards a very large area, what you are doing, you are actually wasting your energy. So with the help of IRS, we are making it more energy efficient. Power required is also much, much lesser. If your energy required is lesser, obviously, if you're catering to a specific user, obviously your power will also be saved some rate. At the end of the day, the major reason behind all this is to have very less interference and to achieve a very high data rate. And for that to achieve, you have to maximize your data rate, you have to maximize your sum rate. Secrecy, you have to make in IRS, one major advantage of IRS is your network your network is trustworthy, it is secured, and it is reliable also. Okay, and last but not the least, you can optimize your coverage. You know where your data communication is taking place, and accordingly you can change the phase shift of your beam. Talking about the performance analysis, you can work on the data transmission capacity. You can also work on the hardware impairment, where you can uh, talk about the various hardwares which are used in device to device communication using IRS. So if there's any problem with one of the hardwares, how do you achieve yet a very high data rate? So that is one. In talking about data rate analysis, it can be uplink. Uplink is from base station to the mobile station. Okay, sorry. Yes, the uplink is from the from the base station to the mobile station. So you can have an uplink kind of an architecture. You can have changing of your phase shifts. So all these analysis could be the future problems on IRS. Anybody who is interested to work on IRS, you can work on these areas, because this is where work or research work can be taken up and can be done. Okay. Then the other is reliability analysis of IRS. You can work on the outage probability, that is the performance. You can work on the phase shift error. You can work on the size of the IRS which has been chosen. You can also work on the potential positioning and the coverage, where exactly the IRS needs to be placed, what is the specific spherical position, where it should be put, and all these things. So if I talk about the open research issues in IRS, you can work on IRS aided UAV communication. UAV is unmanned aerial vehicle. With the help of UAV, you can use it for, or with the help of IRS, you can you can plan for UAV communication, because this is one of the major application in emergency network scenario. In emergency scenarios, when your base station network has failed, IRS can then play a major role in UAV communication. So that UAV in that case could be said to be a part of a base station. Then mobile cell edge computing. We know that any network is very stable around the base station, but around the cell edge, the network strength falls. But with the help of IRS, even those users which are present on the mobile edge, you can give them satisfactory communication at the cell edges also by the help of IRS, by making a beam directional towards that cell edge users. Then millimeter wave and terahertz users. Millimeter wave communication, we already know the major problem in millimeter wave communication is the attenuation, path loss. So if you have to mitigate those issues, IRS can be used for direct communication, which will be able to rectify or mitigate those issues. Also in terahertz communication, it is also very short range communication. Now IRS will be able to remove those problems which are faced in millimeter wave and terahertz communication. IRS aided vehicular communication. Please understand that in case of vehicular communication, there are three parts. There are three types of vehicular communication. One is vehicle to vehicle, one is vehicle to pedestrian, and the other is vehicle to infrastructure. So in first vehicle to vehicle, the vehicle is directly communicating with the vehicle, okay, with the help of roadside units, or it could be a direct communication. When the vehicle is directly talking to the or communicating with the pedestrian, it can take the help of some other technologies. Even when the vehicle is directly communicating with the base station also, that is also possible through the help of an infrastructure. IRS aided localization. IRS is very helpful in localization. You can actually take the help of an IRS in making your communication not only secure, but also make it more localized within a certain area. IRS aided wireless power transfer. Okay, you can take the IRS for wireless power transfer applications also. IRS could be helpful in heterogeneous network. Heterogeneous network is a combination of a network of various other devices. For example, in a heterogeneous network, you can have a base station, you can have a small cell, you can have a cognitive radio, you can have a device to device. All these various other technologies can combine to form a heterogeneous network. So your IRS will also play a major role in heterogeneous network also. And the most important, channel modeling is one of the biggest challenges of 6G communication, because we still don't know how the 6G channel is going to be. 5G channel is known because Rappaport has already done some work in Manhattan in USA using 5G. But as far as 6G is concerned, numerous amount of work is being going on, because it is expected that in 6G channel you will have to have the channel in such a way such that it is not superseded by some of the interferences. So that is why channel sensing and channel estimation is a research work which is still going on, and various works have already been started on 6G channel sensing and estimation. But as of date, no such forward conclusion has come from 6G channel. Okay, so I will end over here. If you have any questions, please you can ask me. If anybody has any questions, you can please ask me.
Hello,
Yes, sir.
participant. You can ask your queries with our expert speaker. So I think, sir, there is no query right now. And if participant have any query, they can directly mail you and discuss with you on your mail ID, sir.
Sure, sure. That can be done. No
Sure.
problem. So
So thank you so much, sir, for such a wonderful presentation and for enhancing our
thank you,
knowledge
sir.
on this topic of IRS-enabled device-to-device communication for 5G and beyond network. And I would like to present the vote of thanks from entire FDP committee members. So I heartily thank
Thank you,
Dr.
sir.
Ranjay Hajara sir for delivering such a nice talk and covering the fundamentals of 5G and 6G technologies, including metaverse and applications, including securities, location monitoring, and integrated IRS system. So I thank you, Dr. Hazara sir, for joining us in the session and sharing light on such important topic of interest. I am also thankful to our
Thank you so much, sir.
respected deans, HODs, faculty members, and participants for joining us today. And at the end, I extend our thanks to all the participants, including faculties who are joining us from our Meerut and all over India in this FDP program. So thank you for giving such a nice talk on IRS.
Thank you so much, sir. Thank you so much for inviting me. And if anybody has any issues or any problem, you can feel free to contact me. I'll be more than
Okay,
happy to answer your queries.
yes,
Thank you, sir. Have a
thank you,
good day. Thank you, sir.
thank you. So participant, we will meet at 1:30 p.m. today in second session, and this session is over. So you can leave this session and we will meet at 1:30 p.m. Thank you to all.
Sir, am I audible?
Very good afternoon, Dr. Surabhi ma'am. I hope I'm audible to you.
Yes, sir, you are audible. Good afternoon.
Ma'am, we are starting in next 2-3 minutes. Let's everyone join.
Yes, yes, sure, sir.
I had made you co-host, so whenever you need, you can share your screen. Good afternoon, everyone. I hope I am audible to all.
Yes, sir, you are.
Coordinator. Thank you, sir. Thank you. I am Kuldeep Singh, the coordinator of the FDP. Welcomes you all again in the 8th session of ongoing FDP organized by School of Engineering and Technology, IIMT University, Meerut. In this session, we have, ladies and gentlemen, it's our pleasure to introduce our esteemed speaker of today's session of ongoing FDP. Our speaker is an accomplished academician with a wealth of knowledge and experience in the field of computer science and engineering. So let's welcome Ms. Surbhi Viz, and let me introduce her in brief. Ms. Surbhi Viz has received BTech Computer Science and Engineering degree from AKTU in 2016. She has received MTech Computer Science and Engineering degree from Amity University, Noida. She was silver medalist there, honored by Sameer Maheshwari, CEO and co-founder of the Health Card in 2019. She has contributed enormous research work in the area of machine learning, image processing, meta heuristics, and soft computing. She has been a keynote speaker in various FDP programs, international conferences. She has published various research papers in international journals, SCI, Scopus, Index, and international conferences also. She has also contributed various book chapters in renowned publishers. She has been active TPC member, reviewer, session chair, PCM in international conferences and journal. She is also the editor board member in Artificial Intelligence in Medical Image Journal. She has been honored with CV Raman Award, CV Raman Award from KITE group of institutions for outstanding research work. She has guided various UG and PG students in their research-oriented work. So with this brief introduction of today's speaker, Ms. Surbhi Viz, let's welcome ma'am for her talk on the ongoing FDP, and the title of her talk will be Artificial Intelligence. So please welcome ma'am. Now you can start your session.
Okay. Good afternoon to everyone. Thank you so much, sir, for the warm welcome. I hope I'm audible, sir.
Yes, you are, ma'am.
Okay. So the today's sessions we are going to see about data analysis and modeling, which plays a very important role when we enter into machine learning or we do the work on artificial intelligence or deep learning, because data plays an important part over it. So let's have a look this. When we talk about the data, basically data analytics is playing a very crucial role in the decision-making process these days for the various kind of applications in real time. Along with that, it is helping, platform is basically helping to reduce the complexity of multiple vendors in real time. And also it is enhancing the marketing strategy when we talk about the data analytics. Further, we can see that because of data analytics. Yes, sir.
Ma'am, आपकी आवाज थोड़ा break हो रही है. Is there any signal problem at your end?
No, sir. There is no signal problem at my end. Am I audible now?
Yes, you are audible, but voice is cracking in between.
Just a second. Sir, am I audible now? Is the voice all right?
It's all right, ma'am. Please go ahead.
Okay. So when we talk about the data analytics, it basically uncovers various trends, various patterns, and helps to determine the correlation in the raw data. So therefore, data analytics plays a major role in various real-time applications and in various case studies as well. So there are different components. There are different different components of data analytics. First of all, there is a descriptive analytics, then there is diagnostic analytics, then there is predictive analytics, and then prescriptive analytics. And each one has different roles. When we talk about the descriptive analytics, it is deals with the application where we determine what exactly has happened. When we talk about diagnostic analytics, it deals why did it happen, such as identifying the tumor, or in medical science, diagnostic analytics is generally being used. When we talk about predictive analysis, it deals with what will happen, such as in risk assessment or in stock market predictions. This is something which is very much used. Then, in prescriptive analysis, we determine how we can make it happen. So these are the different components of data analytics. Another, there are various sources of data. We can collect the data from sensors, from social interactions, from business transactions, or electronic files. So there are various mediums through which the data can be collected. Further, if we understand the classification of the data, it is being bifurcated into 3 parts. Structured data. Structured data, we can understand it is generally the data composed of such as SQL files, such as Excel files. These are the well-defined data which we give as an input to any of the model which we are using. Semi-structured data is something data which is somewhat consistent and has definite characteristics, but it is not being confined, such as XML file which is being created. So it comes under the category of semi-structured data. Now, if we talk about unstructured data, there is no predefined organization. In this case, the input data is basically composed of audio, videos. These all come under the category of an unstructured data. So these are the different kinds of data where actually we work when we will talk about analytics or machine learning or AI. Now, there is a data-driven decision-making process in data analysis and modeling. First of all, the foremost stage is to identify the problem statement. Once we identify the problem statement, then we identify on the sources of data from where this problem can be solved by acquiring some of the information. Now, when we collect the information or collect the data, after that we need to identify whether the data is confined or not. Like, we need to pre-process the data. If we work on Excel files with CSV files, it basically there can be a probability that there are certain missing items. There is some incorrect data, so or duplicated data is there. So that is required to be removed. This process is basically known as pre-processing. Now, if we are taking the data in the form of an images or we are working on video, then in pre-processing we need to filter the data. Filtering technique is basically to enhance the quality of an image. We need to work on the intensity of the image. Then we take that particular thing as an input data. Further, we apply the model. There are various machine learning models that are applied, where testing, training, and validations are performed. And on the basis of this, we determine the various criteria, and ultimately derive or come to the certain inferences or a conclusion. So basically, what is that? It is showing that what is the need of data analytics is to have a more precise decision-making process, more optimized solution to a certain problem statement which we are dealing with, and thus it helps in decision-making process further. Now, this is the life cycle of data analytics, that is discovery, data preparation, again model planning, model building, communicating results, and operationalize. So in each of the phase, we have different roles which is being performed in order to acquire or come to the certain results. If we talk about the discovery phase, basically we identify the business domain, we frame the problem, or we formulate the hypothesis, or we can say we identify the data sources in the very first discovery phase. Once we formulate a certain kind of hypothesis or frame the problem, we come to the data preparation phase. In data preparation phase, basically, we prepare the analytics sandbox where we perform ELT. ELT is a very, very useful term in the industry, which means that we extract, we transform, and load the data. And it is this data preparation phase, various useful tools are there which are used, such as we perform data transformation and cleaning in data preparation phase on SQL, on Hadoop tool, or we can say on Alpine Miner tool, on Mapper tools. Further visualization also can be performed in data preparation phase after cleaning and transforming of the data using the various tools such as R, Tableau, or Spotfire. In the very third phase, there is model planning. So basically, in case of a model planning, we explore the data and performs the selection of variables along with the model as well. We determine which model is required to be applied on that set of data which is being transformed and cleaned in the data preparation phase. So again, there are different kinds of tools which is used here, such as SQL analytics, SAS, SPSS. We can you can explore these tools. They have been very useful and provide very intensive information from certain data sets, which we use generally for solving certain kind of problem states. Coming to the fourth phase, there it is model building phase. In model building phase, basically, we develop the data sets for testing, training, and production purposes, and we determine the workflow of the process. Further, in the fifth phase, that is the communicating results, we identify the key findings, we interpret the results, and quantify the business values, and summarize the findings in order to get to the next phase. In the very sixth phase of an data analytics lifecycle, there is an operationalized phase. In the operationalized phase, basically we run a pilot project. We access the benefit, find the final deliverables, and define the process in order to update and train the model. So this is the basic data analytics lifecycle which is used, and we can explore the various kind of tools where this phase can be deployed, and we can work on it further. So there are various key roles and the needs for the data analytics projects, and accordingly there are different kinds of profiles which is very much in the industry for each of the phases, such as business user, project sponsor, then business intelligence analyst, data engineer, database administrator. For each of the phases, there are different roles and accordingly the outputs are generated. Now there are various applications on which the data analytics is being used, such as in communication and media and entertainment, customer segmentation, self-driving cars. This is very much in application. Then there is virtual assistant, inter-road accident, various data analytics techniques that are used in order to identify the various attributes. Further, in maintenance, it can be used in anomaly detection. It is used monitoring system. In that also the data analytics is used these. We talk about the banking sector. In fraud detection, it can be used. In credit risk modeling, it is used. So there are a number of applications where the data analytics is deployed and used in order to determine the predictive analysis, or to perform the different kind of descriptive analysis, diagnosis analysis accordingly. Now coming to the data pre-processing phase. If we talk about data pre-processing phase, first of all, we collect the data and get the different insights about those data. Further, we perform the data cleaning or data transformations. Data cleaning is basically dealing with removing the null values, identifying the duplicate values in your Excel or CSV file if you are working on that data, then removing those values. Further, there is data integration phase. In data integration phase, consolidated data is being used into a single data set, and ultimately in order to determine the output. Then there is data reduction phase, where we perform the transformation of various numerical or alphabetical digital information, and finally the transformation is performed in order to convert the data from one format to another format as per the case schedule required. Now further, if we talk about data analysis and modeling, data analysis is something to get an insight, and modeling is the set of tools or the techniques which are applied in order to analyze the required data. Now, further, if we talk about supervised, there are three categories which is generally used in ML. First is supervised learning. In supervised learning, there is an output variable, there is input variable. And we apply the mapping function in order to acquire that, in order to get the approximate value. So basically, we can easily understand from this particular image. There is a label data here. That means some input data is already logged with the correct output. So accordingly, the output is being generated and we determine that it is an apple from this particular example. In real world, supervised learning can be used in risk assessment, in image classification, in fraud detection, and spam filtering. So there are different applications where the supervised learning is used. Here we already have that input data, and along with that we have the labels. So basically we do the analysis and we determine the output on the basis of the label data. That is supervised learning. So supervised learning is further classified into two parts, that is the classification and regression. Classification is something when the output variable is a category, that is red hue, absent or present, disease or no disease. So accordingly the classification is performed. And if we talk about the regression, regression is when the output variable is something in the form of a real value. In that case, the regression techniques are being deployed. So one category is supervised. Another category of ML or machine learning where the models are used is unsupervised learning method. Unsupervised learning method is that where we have an input data X and we determine the corresponding output variable. That is, in this case, basically, unsupervised case, the goal is to model the underlying structure of the distribution in the data. Here, the label data is not present. However, in supervised learning, there was label data. Here, input data is not labeled and does not have any known result. So, therefore, we can see in this diagram, we determine the output whether it is an apple, banana, or a mango on the basis where the labeling is not provided. And in this case, the unsupervised learning method is used. And for unsupervised learning methods, there are different kinds of techniques which is being used, such as clustering and the association. If we talk about the clustering, basically in clustering, the same set of problems is gathered into the same group. That is where we want to discover the inherent groupings. Such as, if you take an example, there is a box which is composed of red, yellow, and green balls. So if we need to perform the cluster, all the red balls will be clustered into the one box. Another, the different color will be having in certain cluster, another cluster, and the third color would be having another cluster. So different clusters, that is on the basis of certain attributes, on the basis of certain specifications on the grouping of in data. That comes under the category of an unsupervised case of an ML. And if we talk about association, in association, basically a relationship is formed. That is, get an example, when we go to the mall, there is a case that analysis is performed that if the customer is buying a bread, there is a high probability that the customer will also buy butter. Accordingly, they keep different kind of things in their store. So there we determine the relationship with the help of an association techniques. The third category is reinforcement learning. Now, if we talk about reinforcement learning, it is an area where the intelligent agents are used in order to take a certain kind of an actions in an environment and give back the feedback. And according to feedback, we maximize the performance. And accordingly, the cumulative reward is being determined. So reinforcement learning, in that the agent is there, which plays a very important role because it interacts with outer environment and gives the feedback, and accordingly the improvement is being performed. So here there is a concept of social learning, and on the basis of historical learning, we determine the respective analysis. Now, there are different kind of classification and clustering techniques. So most is support vector machine, artificial neural network, K-means clustering, procedure patient classification. So I have considered each one of the techniques for the further session. Now, if we talk about support vector machine is one of the most used technique in machine learning. It is basically based upon the statistical theory concept. Now, if I talk about the statistical learning theory, it is nothing but a we can understand framework for machine learning drawing from the fields of mathematical foundations or statistical and functional analysis. So basically, this statistical learning theory is dealing with the problem of determining the predictive functions based upon the certain data. And SVM, the most importantly, it is being used in order to determine the decision boundary. The decision boundary, it is also known as hyperplane, and it is supervised learning model, which is associated with learning algorithm. Further, we can easily understand this particular concept with the help of this diagram. See, in SVM, we basically determine or detect the hyperplanes or the decision boundary. Here we can see there are three decision boundaries and we determine which one is best. So in order to determine this particular kind of a problem, we consider the linear separable case of the support vector machine. If we consider the linear separable case, basically we can understand, suppose there is a class of 60 students, right? And we have bifurcated the 60 students into the two parts, that is 1 to 30, 31 to 60. So 30 and 31, these are support vectors. Support vectors are the one which is very nearest to the decision boundary. And this decision boundary is nothing but the hyperplane. So between roll number 30 and 31, there is a decision boundary and hyperplane which is classifying this particular problem statement. So it is a binary set of a problem because here we have lab even batch and B2 batch, and accordingly we have determined the decision boundary. So it solves the purpose of a binary set here. So basically we can understand that SVM are based on the idea of finding the hyperplane that best divides the data set into the two classes. Fine. So further, if we come to the next point, see, as I told, the nearest point to the decision boundary, they are known as support factor, which is highlighted here from the green dots. And accordingly, the margin is being determined for classifying the two classes set. So this is come under the category of a linear classifier, where we determine the maximum margin. And this concept is based upon the problem statement, where we determine the distance of a line from a point. The same mathematics is used here. See, when we talk about the machine learning, more or less, the mathematics is the basic one which has been used, and accordingly, of those mathematics concepts, the model is being framed, and we use that model for the certain kind of an analysis purpose. So here the distance has been observed from a point to the line. This concept of math is used in order to for the SVM linear separable case, and on the basis of this we determine which of the points is nearest to that particular decision boundary on the hyperplane. So thumb rule of this support vector machine is to identify the right hyperplane. It involves the detection of an hyperplane which segregates the data into the two different classes appropriately. But what if it is not? If the case is not linearly separable, that is, what if there are multiple classes? Here you can see in the PPT that here, if there are red and blue dots, this is a very linear separable case, and it easily the decision boundary could be determined. However, what if there are red dots, blue dots, again red dots are there, and we need to determine the decision boundary in this case. So here it will be too difficult to determine the decision boundary because we cannot classify the data very easily. For that case, we convert the lower dimensional to the higher dimensional space. And in order to convert the lower dimensional to the higher dimensional, we perform the mapping functions. If coming to the mapping functions, there are various mapping functions in the form of the kernels, which is deployed in order to convert the lower dimensional space to the higher dimensional space, so that the classification can be performed appropriately. In order to perform the classification appropriately, these are the kernels which have been deployed, such as linear kernel. They are basically, we can understand set of mathematical functions which is used in order to take the data as an input and transform into the required form. We can also see in this diagram that in order to determine this decision surface, the kernel is used, and these kernels are of various types, which is deployed in order to determine the hyperplane from a highly complex data. So accordingly, there is linear kernel, there is polynomial kernel, radial basis function, and a sigmoidal function. And these kernels are nothing but they return the inner product between the points in a suitable feature map, and accordingly determine the boundary. Further, there are various applications where the particular kernels are used, such as in time series data, it can be utilized. It can be used in machine learning, machine vision. It can be used in text categorization or in anomaly detection. So there are different phases where it can be utilized. Further, coming to the artificial neural network. So artificial neural network is a method in which there is input layer, there are hidden layer, and there are output layer. And in each layer, there is an activation function which is being applied, and a different parameter are utilized in order to do the predictive analysis. It helps in discovering a various kind of patterns. In order to understand the basic, we need to understand the concept of the perceptron. So basically, here there is a neuron which is receiving the input in the form of x1 and x2, and further the weight is being assigned, and we formulate basically the sum of this weighted input, which is given as a further this calculated weighted total weighted input is given, and accordingly activation function is applied to determine the threshold value. So here weighted input is utilized, for the activation function is applied in order to determine whether it will get triggered or not. So if the total, here we can see the values ranging between 0 to 1. And if the total weighted input is greater than or equal to the threshold value which is mentioned here, the neuron will get provide the output. And if the total weighted input is less than the certain threshold value, no output is produced. So coming to the feed-forward network, in the feed-forward network, here each perceptron in one layer is connected to the every perceptron in the another layer. So this is a concept which is used in the feed-forward network, where each of the perceptron, each first layer is taking the input, and the last layer is producing the respective output. Coming to the recurrent neural network, there is an arbitrary topologies in recurrent neural network, and training is quite difficult in it. So sometimes performance may be problematic in this case due to a certain kind of an oscillation. If we talk about the layers in neural network, there is input layer, hidden layer, and output layer. In hidden layer, basically activation function is used or other processing is performed. Further, in hidden layer, two hidden layers are sufficient to define any kind of problem. Output layer determines the respective output. Another, there is a backpropagation. So backpropagation is a neural network which computes the gradient of loss functions for a single weighted by a chain rule. That is, we can understand that it is a method of fine-tuning of weights of a neural net based on the error rate which is obtained in the previous iteration or previous epoch. So backpropagation is a short form for backward propagations of error. This concept is basically determined by the backpropagation neural network. here, for a given set of training input output pair, this algorithm will be providing a procedure for changing the weights in backpropagation neural net in order to classify the given input correctly. So here there is an input there which arrives the pre-connected path. It is modeled using the real weights W. Further, we calculate the output for every neuron from an input layer to the hidden layer and to the output layer. Further, we calculate the error in the output. So error is basically calculated when the actual output is subtracted, actual output minus the desired output. In this way, we can calculate the error. And further, we travel back from the output layer to the hidden layer in order to adjust the weights so that error can be decreased. And we keep repeating this process until the final output is achieved. So the backpropagation algorithm works here by computing the gradient of loss function with respect to the weights by the chain rule. So further, this concept is utilized in the backpropagation case. There are various applications in which it can be used. It is using technical diagnostic for intelligent or signal processing in the development of an intelligent support system, security system for pattern recognition for machine vision and various other applications. Coming to the concept of k-means clustering, basically, in this case, we select a k number of an object set in random in order to determine the centroid point. So here, for each of the objects, each of the remaining objects, it is assigned to one of the closest centroid which has been calculated using the certain formula such as Euclidean distance. On the basis of that, we determine the cluster centroid for each of the clusters, and accordingly, we update this procedure until we meet to the stopping criteria. Till that, the number of iterations is being repeated. So in this case, we determine the centroid point for the clusters on the basis of a distance matrix, and accordingly, the clusters have been formulated and computations are performed. When we come to the decision tree or the decision tree, basically here the top-down recursive or divide and conquer approach is being utilized in order to frame up the trees, and there are certain stopping criteria for the decision tree, such as all the samples for a given node should belong to the same class. There should be no remaining attributes for further partitioning of this. On the basis of that, we determine the stopping criteria. So this concept is based on the information gain and entropy, and accordingly generate the decision tree. Information gain basically measures how good a given attribute is, separating the certain training example according to the target classification problem. And this measure is basically utilized in order to select the amount of candidate attributes until for each of the steps while doing the tree. And in case of an entropy, we determine the measure of homogeneity for a certain set of examples. So basically, here the tree is being determined, and after formulating the tree, we classify the problem state. If we talk about Bayesian classification, so a Bayesian classification problem is based upon the concept of probabilistic prediction and probability, where the basis is utilized in order to classify the certain set of a case study or a problem statement. Here, each training example will be incrementally increase or will decrease the probability of a certain hypothesis, and accordingly, the optimal decision making is being determined. There are various problems, there are various algorithms which can be utilized, such as Bayes, where the concept of Bayes theorem is utilized and the maximum posterior hypothesis is determined in order to on certain set of an hypothesis to come to the certain output. So I will show the implementation part for it. A second, I'm sharing the screen part. I hope the screen is shared. Is the screen is visible? So basically, the algorithms which we have discussed recently, such as SPM, ENN, KV, cluster intersector, this is the practical implication of it. Here, if you can see on the screen, we have imported the conduct library and then we have created the iris CSV file. So iris file is basically composed of the different flowers. We have taken that data. Shape function is utilized in order to determine the rows and the columns. So we can easily see that there are 150 basically rows and 6 columns is utilized, such as petal length, petal width, height, and so on, different attributes. We can understand there are different attributes and respective outcomes for those attributes, and respective outcomes is in the form of the classes such as Secosa. You can see that here is vertical. So there are 3 classes in this case in the data set: vertical, Setosa, and Vajnika. So 3 classes have been considered in this, and with the parallel function we can determine or see how the data set looks like. Further, the head function is utilized in order to see the top 4, in order to take the understanding of the insights of the top 4 rows, and the take function is utilized to determine when we, if the suppose if the data is too large and too complex, in order to get the insights of the data, this function can be utilized. Further, the column function is being given in order to see what all attributes are there in that particular data set. Further, determine the type of that particular data set, and then we call the describe function from the data frame in order to determine or perform the different statistical operation in it. Further, we check whether there is any duplicated data or not, and we determine the count of each of the classes. We can see there is 50 rows for the vertical, then Serota, and then Vajnika. Basically, there are 3 classes which is there in the data set. We determine whether there is any null value or not. If there would be a null value, duplicated value, we would have to perform the pre-processing in order to remove all those stuff. Further, the visualization is performed on these data sets in order to determine the pattern of data and get an insight of the data set. So there is a different kind. I put a blank of it. Different kinds of patterns have been understood by the graph, such as scatter plot. Here we can see there are, if we see carefully, the iris Setosa, that is the vehicle and dots are there on the one side, whereas vertical and Vajnika are mixed, which shows that one is independent of another and another one is both are dependent upon. So then we implemented the pair plot. And finally, we determine the correlations between the different attributes in order to have an insight. And each map is plotted further in order to determine whether which of the attributes are dependent or independent, and for to determine the correlation or relationship between both attributes. If we see further, box plot is also being plotted. Here, the decision tree is plotted. Decision tree algorithm is being implemented. As we discussed the concept of information gain and entropy while implementing the decision tree classifier, here we have taken the features, imported the dataset as well as libraries. Then we have defined the axis and the y, that is the target, that is vertical Setosa and Vajnika, as in we have given in target for the y-axis. And further, we have implemented the model, that is the decision tree for the classification purpose. And here we have fitted the data for the training and testing purpose and plotted the decision tree on the basis of the heavy index or the droplet of information gain. We have also discussed the SVM in the previously in the slides. So SVM basically classifies the data. Here also we have imported the data set. Then we have done the model selection and imported training testing. Also the considered metrics in order to acquire a certain performance metrics. Performance metric in a sense, the certain kind of accuracy, sensitivity, specificity, F1 for applications of an model. While implementing it, we have given the various after training and testing. Here we have split the data into 7:3. That is 70% of the data is utilized for training and 30% of the data is utilized for testing purpose. We have applied the different functions and parts the parameters in order to determine the respective output. So here we can see that when we use the testing and training data in order to predict the acquired accuracy of 91%. Further, the k-means clustering is applied. K-means clustering determines the number of clusters, and in that number of clusters, we determine which all attributes are connected with each other. And further, after implementing this particular model, that is the k-means clustering, we have also plotted the scatter plot in order to see the visualization part of it. So here we can see we have determined the with the help of k-means clustering, we are able to segregate and determine the endpoint point for this particular cluster, that is the red points, which is coming under the category of Cytosa, and then blue point, which is coming in the category of versicolor. Further, the Virginica, which is coming displayed or depicted with the help of this color, and accordingly the center point is shown here. Further, we can see we talk about ANN. We have imported the libraries and the sequential model is utilized. Further, we have performed the training and testing of data and given that category, converted that target class to the categorical ones for both training and testing. Therefore, we can see that for iris it also will represent 0 for versicolor 1 and again this. After using the sequential model, we have parsed the different layers, and in different layers we have parsed the neurons, we have parsed the activation function, and we can see that in the it is a multi-class problem which has solving the probability distribution of it, and here the activation function softmax is utilized in the last layer for ANN. Further, we have given the loss function as in category entropy. There are different kind of a loss function which can help parameters could be changed accordingly depending upon the computation combination using, and accordingly the model will generate accuracy for the problem statement or the case study which you are solving, and the respective output is being generated or accuracy is being computed here. So this is about the entire session where we have discussed related to the different machine learning techniques such as support vector machine, artificial neural network, and then we have seen the k-means clustering under the concept of name-based or decision tree, and we have seen the practical implications of it. That's all about from my side for this particular session.
Thank you so much, Surbhi ma'am. This was a fabulous lecture. I must congratulate you for this knowledge enhancing lecture for all. I hope everyone has enjoyed this lecture.
Yes, sir. Thank you so
much. Most welcome, ma'am. Now I invite everyone, if they have any query, they may ask to ma'am. Ma'am is right available there. If anyone has any query regarding this lecture or they want to know something about it, they may ask. As I can see, no one is coming forward. So we may thanks to the speaker of this session, Ms. Surbhi Viz ma'am, for this wonderful lecture. She thrown the light on the various aspects of data analytics and artificial intelligence. So in this FDP, this lecture is again and very important. This was a very important lecture and incorporated the title of the FDP. So thank you so much, ma'am, for considering our request to deliver the lecture. We also request you to take some, most welcome, ma'am. We also request you to take some more offline lectures too in SET whenever we request you.
Sure, sir, sure.
So on the behalf of whole SET team, we thanks to you for the wonderful lecture. Thank you so much, ma'am.
Thank you so much, sir, for the warm welcome as well as for inviting for this particular lecture. Thanks.
Yeah. So that concludes this session number 8, everyone. All the participants are requested to kindly join at 9:15 a.m. tomorrow for the next session of this ongoing FTP. For now, thank you, everyone. Thank you so much.